Welcome back. Today we're going to look at section 1.4, which is going to be our one-sided limits. When we're talking about a one-sided limit, we're looking at a function or the branches of that function from one side or the other. And we call that the left side or the negative side, or we can talk about the right side or the positive side of a function. So the way we're going to show that, our notation here, is going to be taking the limit as x goes to a. Again, a is going to be some value from the positive side. So we're going to superscript a little plus sign up there to show that we're looking at the positive side. Well, what does that mean when we talk about a graph? So if we have a branch coming in this way, and maybe this is our a value here, and then maybe we have coming from this side. So if we're looking at the positive side of a, the positive side of a is going to be on the right side. So we're looking at this branch coming to a, and the right-sided limit, or the positive side of this limit, is going to be this value in here. Likewise, if we took the limit as x goes to a from the negative side, that would be looking at the negative side of a. The negative side would be the left side. So now if I'm talking about the left-sided limit, I'm looking at where this branch comes here. So when I'm talking about a one-sided limit, our two branches don't have to come together anymore in order for the one-sided limit to exist. So if it's positive side, we're looking at just where does that positive branch go. The negative side, we're looking at where the negative side goes. This is going to be very important when we go into continuity in our next lesson. So we normally use one-sided limits when we describe a piecewise function. Remember, a piecewise function, we'll write it up here. It could be f of x equals, and then we have this brace where we split up our function, maybe x if x is less than or equal to 2, and maybe 2x plus 1 if x is greater than 2. So notice this lends us very, very nicely to the left side and the right side. So the left side would be the less than side, as well as maybe you want to put the less than symbol up there as well. And then the positive side would be the greater than side, because the number greater than 2 would be to the positive side of 2. All right. So one thing we want to remember is that first rule of limits. Remember, the first rule of limits is if we can plug the value in to the function itself and it comes together and we get a value out, then that's going to be our function. And that's going to be our limiting value. So looking at example 1, we have the limit as x goes to 2 from the negative side of x minus 5. Well, x minus 5 is just a linear function. So it doesn't matter if we're coming from the negative side or the positive side. This function, we know is a continuous function, so we know that the left and the right side of the branches are always going to be coming together. So if I plug 2 in for my x value, I end up with 2 minus 5, which gives me negative 3. So that's going to be the negative side of 2. It also, coincidentally, is the positive side as well, because if we plugged in positive 2, then 2 minus the 5 gave us a negative 3 as well. So this is an example of where it doesn't necessarily mean a whole lot to us from the negative side or the positive side. Once we get into our piecewise, it does get to be a little more important. So looking at example 2, we're looking at the limit as x goes to pi from the positive side. If I'm interested in pi from the positive side, I want numbers that are larger than pi. And if I look at this piecewise function, I'm describing x, or the function, when x is less than pi, equal to pi, and greater than pi. So with this one-sided limit, I'm only interested in the greater than side. So from the positive side, I'm looking at the sign, this should probably be an x there. So I'm looking at the sign of x if x is greater than pi. So what I can do is plug my pi in, and I get the sign of pi. And the sign of pi, hopefully we know, is 0. Again, that goes back to our unit circle. Pi is over here, and we have the point on our unit circle, which is -1, 0. All right, and that gives us our one-sided limit. So we're really not interested in the less than or the equal to sign when we're looking at a one-sided limit from the positive side. In example 3, we're looking at x going to 1 from the negative side. Well, from the negative side, again, the negative side is going to be the less than side, the left side. So I'm only interested in this first part of my function. Here I'm going to take my 1, I'm going to plug it in for x, and we end up with 1 plus 1, which gives us 2. So as x approaches 1 from the negative side, this function goes to 2. And we could graph this out if we want and see that. So if I were to graph x plus 1 is less than, when x is less than 1, here's our 1. I'd be up here at 2, and it would be coming as a positive slope. So we should see that from the negative side of this, so when I'm here at negative infinity, working my way toward 1, this function is getting closer and closer to the y value of 2. Again, I'm not interested in what's on the right side or the positive side of this function at this point in time. As we look at the limit going to just a value, this is where the positive and negative sides now are very important to us. So what has to happen for the limit to exist at a value? Well, that means that the limit from the positive side and the negative side of f of x are going to equal each other. So I'm looking at the limit as x goes to 0 from the positive side, and the limit as x goes to 0 of the positive side, negative side and positive side to equal each other in order for that limit overall to exist. So if the limit from the negative side and the limit from the positive side are equal, then the limit overall is going to exist. So that's what we're going to test. We're going to test, do these two things equal each other? Well, from the negative side here, I'm looking at x plus 1. So I'm looking at 0 plus 1. And I want to know, does that equal when I plug in 0 on the right side from the positive side? So in that case, I get 2. Does 1 equal 2? In that case, it does not exist. That's not true. So since these are not true, 1 does not equal 2, obvious, then the limit as x goes to 0 of f of x does not exist. Again, in order for it to exist, these two values would have had to have been the same. In example 5, our last example, we're going to go ahead and look at the limit as x goes to negative 4 of f of x. Again, we're looking at a limit to exist overall, then from the negative side of f of x has to equal the limit as x goes to negative 4 from the positive side. And that's the question we're asking. Do those two things meet up at each other? Do those two branches come together? On the left side, or on the negative side of negative 4, I'm looking at the top part here. So I'm going to plug in my negative 4. I get negative 4 minus 1 gives me negative 5. Does that equal when I plug in negative 4 into the right side or the positive side of this function? So here I have the negative of the absolute value of negative 4 minus 1. The absolute value of negative 4 minus 1 is negative 5. Absolute value of that is 5. So I get negative 5. Since these two values equal each other, then this limit exists as well. So we say the limit as x approaches negative 4 of f of x equals negative 5. And that gives you an example of one where the limit doesn't exist overall and a limit where it does exist overall. Happy limiting!